In this video, we'll be looking at our third transformation, and that is rotations. A rotation, or turn, is a transformation in which every point moves along a circular path around a fixed point. So you can think of those swing sets that go around a fixed point, and everything turns as it goes, or a Ferris wheel that goes around. But what it is that point is going around that fixed point. When we do rotations, unless stated otherwise, rotations are in the counterclockwise direction. So if you think of a clock would normally go this way, but counterclockwise means we are going to go opposite, so this way. That's how we're going to do our rotations. With the center of the rotation at the origin. So if you think of A as your pre-image and you rotate 90 degrees counterclockwise around the origin, then it's going to end up in quadrant 2. So if you remember your quadrants, there's quadrant 1, 2, 3, and 4. Okay, so whenever you rotate 90 degrees counterclockwise, it moves one quadrant. When you rotate 180 degrees counterclockwise, it moves 2 quadrants. And when you rotate 270 degrees counterclockwise, it moves 3 quadrants. It's important to note that you do not have to start an object in quadrant 1 to rotate it. If this is my pre-image and I rotate 270 degrees, it's going to move 3 again. So 1, 2, and it's going to end up right in here. There are other rotations that do exist. You can rotate around other points, but we're mainly going to focus on the center being at the origin. All right, so let's look and kind of see how rotations work. Point A here on Santa's sled is at 7,4. If we rotate this 90 degrees, so we're going to line that up so it's 90, you can see that your new point moved over to negative 4, 7. So you see some correlation with the numbers here, even though signs are a little different and they're in different places. Let's rotate another 90, so we've done a total of 180. And that puts us at negative 7, negative 4. So once again, I still have the 7 and 4, just they're different places with the signs being different. And one more rotation to do another 270. Puts me at, if you look here, 4, negative 7. Well, for fun, let's do 360 and see what happens. It ends up right back where it began. So when you do a 360-degree rotation, you end up back at 7,4. So it looks like there's some pattern that rotations follow. Here's the pattern they follow. When you rotate an object 90 degrees, the xy, the new rule becomes negative yx. In other words, what this is saying is that your old y that you started with, that specific number in that place, moves into the first location where the x was. And it changes sign. So if it was a positive, it's going to become a negative. If it was a negative, it's going to become a positive. And the first number moves to the back without changing signs. For example, if you have 2, 3, that's going to become, well, 3 is second, so it's going to move first, and it's going to change signs, so negative 3, 2. When you rotate 180 degrees, all that changes is you change both signs for x and y. So if x is positive, it becomes negative. If y is positive, it becomes negative. If x was negative, then it would become positive. So you see this negative, all it means is change the signs. When you do a 270-degree rotation, once again, the y moves up to the first location, but this time it stays the same. The x moves to the second place, and it changes sign. So if you'd started here with, let's say, negative 3, negative 4, well, the y would go up first, so negative 4, comma, and then negative 3 would go to the back and change signs, 3. So let's practice here. We have O at 0, 0. We have P at 3, negative 2. And we have Q at 2, 5. We're rotating this thing 180 degrees. What I want you to do is write the rule first and then try the rotation to see what you can do. So pause the video and try it. All right, so we need to write the rule for 180-degree rotation, and that's going to be, of course, xy will give me negative x, negative y. So O prime, well, 0 as a positive or negative, still the same, so 0, 0. P prime, so change the 3 to a negative 3, and then change the negative 2 to a positive 2. For Q prime, negative 2, negative 5. So if you graph that, 0, 0, negative 3, 2, and negative 2, negative 5. This would be your new rotated 180 degrees triangle. All right, so here we have V, which is at 2, 2, W, which is at 2, 4, X, which is at 6, 4, and Y, which is at 6, 2. Now, notice the strategy I'm using here is I'm writing all my original points to the right of your graph. On your homework or practice, you really should do that as well. Write the points to the side before you try any rotation. So in this case, we're rotating 270. So write the rule, try it out while you pause it. All right, so 270, the rule is y negative x. So for v prime, the y will come first, so 2. The x will go to the back, and it's going to change signs, so negative 2. W, y comes up first, so 4. 2 goes to the back, changes signs. X, and y comes up front, 4. 6 changes signs. Y prime, 2 comes up front, 6 goes to the back, changes signs. So we graph it, and we get this guy right here. Notice it's not facing the same direction. That's okay because it's rotating around the figure. All right, I want you to definitely pause and try these 4 out to see if you can get the new location of these points after rotation. All right, so for 270 degrees, my rule is y negative x. So 2 comes up front, the x changes signs. For 590 degrees, negative yx. So the y comes up front, changes signs, the x moves to the back. 270 once again, y comes up front, x moves to the back, changes signs. And then finally for 180, both change signs, so negative 7, positive 3. And finally, as a review before we end, see if you can list what each of these would be an example of. It could be any of the transformations we've learned, including translations, rotations, and reflections. All right, this first one is an example of a reflection over the x-axis because x stayed in location and y is what changed. This is an example of a translation up 4. This would be a 90-degree rotation. Here we have a translation that is left 2 and down 3. This is a 180-degree rotation. And finally, this would be a reflection over the y-axis because the y stayed exactly the same. Make sure you do your homework for this unit and get good practice. Thank you.